Hi, welcome to the Calculus 1 lecture series. And this is a video for the lecture number 8. And from this video, we're going to start a new unit. And this new unit is about derivatives. And, in the first unit, we talk about the limits and the derivative. We kind of start to define how to use the limit concept to define the derivatives, right? So because basically the derivative is kind of like, is defined as the slope of the tangent line. And then the tangent line is the slope of the second line. Now, when the difference between the 2 points gets smaller and smaller, right? Okay, so this unit is kind of like a pretty mechanical unit here. So we're going to talk about, instead of using the limit definition to find the derivatives for certain functions, we're going to introduce many different formulas so we can apply it directly instead of using the limits to try to derive it. So we're going to talk about all different type of the formulas here. So for this lectures here, we're going to talk about the couple of formulas, the derivative of the polynomial and the derivative for the exponential functions here. Okay. All right. So now let's go ahead and go to our lecture notes here. And so here is our lecture notes here. Okay, so let's, like we talk about, let's go ahead and let's start here. So first things here, we talk about derivative rules. So after the chapter, this previous unit, start from this unit, we're not going to use the limit definition to find the derivative anymore. So we're going to apply the formulas here. So we have a few things here. The first ones here, the first formulas here is the derivative of a constant. Okay, so this is we said a derivative of a constant. So the derivative of a constant function is 0. Okay, that means if f of x equal to a c, then f prime x equal to 0, because we know from the definition, if a function is a constant function, that means this one here is like it's a horizontal lines, right? So for the horizontal line, then the slope of this one. So every point, the tangent line is the same as the line itself. So the slope equal to 0. So that is pretty obvious. Okay, so that's the first rule. And then the second rule is we call it is the general power rule. Yeah. Okay, so what is the general power rules here, right? So the general power rules tell you if f of x is here is equal to x to the nth power, so the n could be any numbers here, right? So the a, could be whole number, fraction, negative numbers. Then when we talk about f prime x, so what is this one here? Will just be you move the n to the front, so it will be n times x, then the top is -1, n times x minus 1. This is what we call is the general power rule, right? So that's what we call this is the power rules here. Okay, now the third rules here we call this is the constant multiply. What means a constant multiply? That means if you have a constant times f of x, right? So if you have a constant times f of x, then if you take the derivatives, okay? So then you take the derivative, will just be equal to the constants times you take the derivative of the functions here. Okay, so we're going to practice here. So that means if a constant time function, and then you just kind of bring the derivative inside, then the constants stayed here, right? So be careful, let's the constants stayed here. That's what we call this the constant multiply. Then the number 4 here, we call this the sum rule. That means when we add, okay? So what does that mean? That means if I have f of x plus gx, then if you take the derivative here, so what it will be? It will be the f prime x plus g prime x will just be equal to, you take the derivative each individually and then add them together. Then the rule number 5 here, we call this difference rule. Okay, that means if you have f of x minus gx, then if you take the derivative, what is it going to be? It's going to be the f prime x what minus g prime x. So you can break this parentheses here. Okay, now let's take a look at what do we have here. Okay, so the first ones here, we said f of x equal to the 5x fourth. So here the phi is your constant, right? So I'm going to use the constant multiply rule. So we'll just be, so f prime x will just be equal to the phi times. And then what rules I'm using for the x fourth here? I'm using the power rule, right? So you move the 4 to the front, then the top will be 4 minus 1, right? So that's what is n minus 1 mean. So what is the final answer? So this is 20 to the x to the what? To the 3. Okay, now let's take a look at the second ones here. So this is f prime x. So this ones here is the sum of the two functions. One is x fourth and one is 4x cubed. So we use the sum rule. You can take the derivative of each term, then add them together. Okay, so x fourth, how do I take the derivative? Power rule, right? So you move the 4 to the front. Now here, this is x, what is the exponents is 4 what? Minus 1, right? Okay, then plus 4, you move the 3 to the front, it's 3, right? And then times x to the what? 3 minus 1. Okay, so what is the final answer? So this is 4x to the cube, and the 4 times 3 is what is 12x to the square. Okay, so now part C is the same things here. Right now, I just have more than 2 terms. So I do the same thing. So 7 you put here, you move the 3 to the front first, and then x the 3 minus 1 plus 6. Then you take the 2 down, right? And this is x the 2 minus 1. Then plus 10 times, so what is here? This is 1s, right? So times 1s here, then this is x to the 1 minus 1 power. And what is 12 here? 12 is what? It's a constant. So what is here? Plus 0. Okay, now let's try to simplify. This is bit. 7 times 3 is what is 21 to the x squared. 6 times 2 is 12x and plus 10, right? So what is these terms here? This is x to the what? This is x to the 0 term. So what is the x to the 0 term? Is 1s, right? So that's why I just have to 10 left here. Okay. Okay, now let's take a look at these ones here. Okay, so these ones here, so the f prime x, now my components here is negative, right? So, but we say it doesn't matter. We still do the same here, right? So here, that will be what? You move what here? Move negative 7s, right? Now here, this is negative 7 minus 1, the power rule, right? Then minus, you move the negative 6 down. Now here, this is negative 6 minus 1. Okay, so now here, this is negative 7. Be careful, what is here? Negative 8, right? Then negative is a positive 6. Negative 6 minus next 1 is what? Negative 7, right? Okay, so now E, that's just our formula. So f prime x, what is f prime x? Is n to the x what? Minus 1, right? Okay. Okay, so now in here, the part f here, we're going to talk about this is f of x equal to x plus 1. Okay, so in here, we know the general powers rule is xn's, right? So then the derivative will just be n to the x minus 1. So remember here, right? So it's only x here. But in here, I have x plus 1. It doesn't match my general powers rule, so I cannot just move down. Even the final answer will be similar, but we cannot, so the way we do it, let's FOIL it. Right? So if you FOIL it, you will have x squared plus 2x plus 1, right? Now you can take f prime x. So what is f prime x? You take the 2x and this is 2 minus 1. And be careful. So this is what? This is x to the first power, right? Okay, so then this will be plus 2 times 1, then the x 1 minus 1. Then here is what? This is a constant, correct? Because the, the 1 is the constant here. And now you simplify this. This is 2x plus 2. And here is again, this is x to the what? This is x to the 0 power is 1. Here is 2x plus 2. And now if you factor 2 out, the 2, the x plus 1 is here. Okay, then you might say, hey, I can just use the general powers rule to take it directly. I want to tell you, for this problem, yes, they will be the same answer, but you are just lucky. And in general, if you have any other function here, they might not be the same answer. That's why we need to wait for about 2 or 3 sections later. We're going to introduce what we call the chain rule, right? So to handle this type of problem. So for here, we have no choice. We have to FOIL it, okay? Okay, so now let's take a look at the last ones here, okay? So the last ones here, the f prime x here, okay? So what is that? Okay, so this is x to the 5th to the cube roots. So in order to use powers rule, let's first change this one to the exponents. So what is this exponents is 5 over what? 5 over 3, right? So the cube roots is a denominator. So now the f prime x will just be the same. You move the exponents, right? 5 over 3 to the front. Now here's x. Now here this is 5 over 3. Now what? Minus 1, right? It's n minus 1. So here this is 5 over 3. Then what is this? 5/3 minus 1 is what? 2/3. Right? That's the answer. Or if you want, you can rewrite this is kind of like x to the square, the cube roots. All right? Don't waste here. So remember, those rules are pretty easy here. Okay. Okay, so now the next things here, this is really just try to test you to see you remember the definitions here, right? So let's say the position function, there's a position function of a particle is this one's here. I want to find the velocity function, right? So this is what tell us, like if f of t, remember we wrote this, if the f of t is the position function, right now we know the first derivative is what? That's the velocity. That's the velocity function of this particle. Then what is the second derivative? If you take the derivative again, this is what we call the acceleration. Right? That's what the 3 things we need to remember. So in here they say, hey, let's try to find the velocity when x equal to 2. So you say, okay, so then the first things that I need to do is try to, right now the variable is t. So we need to try to find f prime t. So this is the t square, right? So let's let's be careful here. So let's rewrite this. This is t squared. What is 1 over t? Is t to the what? Negative 1s, right? Okay, so now f prime t, we just take the derivative, right? So it's 2, move the 2 to the front. So what is the exponents? Is 2 to the 1. Okay, so 1 over t is t to the negative 1. So what is the power rule? So will be half. You need to move the 1, negative 1. So what is here? This is x to the negative 1 minus 1, correct? Okay, now if you simplify that, this is 2 to the what? T, right? Then minus, this is what? This is x to the what? This is x to the negative 2. Basically, if you want, you can put this is 1 over t squared. I'm sorry, it should be t. And I need to be careful about the notations, right? So this is t. So this is the velocity function. Then they ask for the t equal to 2, you just plug the 2 into the f prime. So this is 2 times 2 minus 1 over 2 to the square. So 4 minus 1/4. So it's 3.75 meter per second here. Okay, right? Okay, so now let's take a look. And so let's say for the f of x equal to mx plus b, and find the f prime x, what does this say about the tangent line to the points here? Okay, so we know the f prime x. So this is, you can treat it as the x to the first powers, right? So you just equal to the m. So this is a constant multiplication. Move this 1 down. Then here, this is x1 minus 1. Now, what is the b here? B is a constant, so you plus zeros here, right? Okay, so that's why you will get an m. And this one is the same thing. X to the 0 power. What is this one? It's 1, right? So this is m. Okay, so that means it's the slope here. So we know it's a constant, right? So the derivative is a constant. Okay, so that means the tangent line so that means the tangent line always has slope what? Slope m's, right? Because we know the derivative is defined at the slope of the tangent line, and because this is the line, the slope intercept formula, right? So it could be like here, right? So every point in here is the tangent line for that. Okay. All right. So now the next things here, we're going to introduce these functions here, the e functions here, right? Okay. So the e functions here. Okay, so the way we define the e is like this. Okay, so we said the number e is a constant. Okay, so how do we define this constant? This is how we say that. That means limit h approach to 0, and this is h e to the h minus 1. And if this limit equal to 1, then this is how do we define this e's here, right? So be careful, e is a constant. And what is this constant means here? That means the e going to is approximate to 2.71 So E is a type of the, so E is a type of the constant, similar like the pi is irrational. It's never end. It's just going to continue, Okay, so now in here, let's take a look. So what is the derivative here? The derivative for So the derivative for e exponential function, this is very good. So if f of x equal to the ex here, all right, then the derivative is always, so derivative will be equal to itself. This is one of my favorite function because the derivative is equal to the original functions here. Okay, so like in here, let's say, okay, so the number 4 is here. It asks you, say, what number of k is this one equal to 0? So we know, if this limits here, the k to the h power minus 1 over h equal to 1, I only have one value. So what numbers here? So we know k has to equal to the e is the only number. Okay, so that is our definition for the e's here. Okay, let's take a look at the truth false here. So let's say if f of x equal to the ex, then the f prime x equal to f of x. This is true or false? This is true. That's what is the derivative of formulas, right? So they said if the f prime x equal to the f of x, and then f of x has to be equal to the what? Has to be equal to the ex. Is true or false here. Okay, so this is what? This is false. It doesn't have to be only ex here. So for this ones here, so for examples here, right? So if you say that f of x equal to a constant 5ex, so what is f prime x? Is 5ex is still equal to what? F of x. But f of x doesn't have to be ex only. You can have any constant here. Okay, now let's take a look at the derivatives here. Okay, so let's set up, find each of the following here. Okay, so this one's here, the f prime x, remember the 3 is a constant, so it's a constant times. What happened to the ex? Like we say, we always love it, so it's e to the what is ex. Okay, this one is a little bit tricky here. So what is the f prime x? We said the f of x is e3. Okay, so this is E3. That means is 2.712a. So this one is equal to the 2.712 to the what? The 871A28. So I kind of okay, 71A28 to the third power, right? So this one is what? There's no x. So this really is just some number, right? So it's some constant. So what is my f primes here? It's 0. Get that? Okay. Now in here, this is f prime x. And then take a look here. This numbers here, this is 1 over 10. So this is really, you can write this is like a 1 over 10 to the e to the x. Then you use the constant multiplication. So what happened here? This is the constant you stayed here. Then the ex will be what? Just by itself. Okay, now here, be careful here. Now the last one's here, the f of prime x. So here, look here, right? So this is e. Okay, so this is e times x. All right, we know e is a constant. So the x here is power 1, right? So what is the first derivative? It will be e, then times you move the 1 to the front, then the top will be 1 minus 1, right? Then the second function here, so this ex, we know the ex by itself, now what is the derivative will be the what? It's the same things here, ex. So now here, like we did many times before, x to the 1 minus 1, this is x0 is equal to 1. So what is the final answer? Will be e plus ex. Okay. All right. so now let's take a look at these ones here. The last ones here, find the equation of the tangent line to the graph. Okay, remember the tangent line, what is, in order to find the lines, right? So here, in order to find the line, we know we have to have the slope of that line. So what is the slope of the tangent line? We keep mentioning that. What is the slope of tangent line? It's derivatives, right? So, okay, so we need to find the derivative here. Okay, so now let's take a look. Well, let me put here, give me a little bit more space. Okay, all right. So in here now, in here, let's say here. Okay, so the first things I need to find f prime x. All right, so this f prime x, so this is 2, move the 2 to the front. X, what is here? 2 minus 1. Second term, what is the ex to the derivative itself here, right? So this is 2x plus ex. It's good. Okay, so now you say x equal to 3. So that's why I plug the 3 in here. So what is here is 6 plus e3. So what is this one? Remember, this is the slope, right? So this is the slope of what? The slope of the tangent line, all right? So in order to get a line, I have a slope. Then I also need to have a what? A point, right? So for x equal to 3, now I need to plug in the x equal to 3 to the f of x to get my point. So you plug in, so this is 3 squared plus e3. So what is here? So it's 9 plus what? E3. So this is my point. So I have a 3 and 9 plus e3. So we use the formula slope and the 1 point. Let me write down here. So slope and the 1 point is y minus y1 equals slope times x minus x1, correct? Okay, so now we can do that. Okay, so now I can say here, so it's y minus 9 minus e3, all right? Be careful, the minus need to carry through both. Is equal to the slope. So it's 6 plus e3, the whole thing, times what? X minus 3. Okay. All right. Okay, so now if you simplify this a little bit, so basically you can just say y is equal to the 6 plus e3 and to the x, right? And then you'll be able to, and so this will be minus 2 to the e3 minus what? Minus 9. So basically you just move this one to over here, right? So what you do, you just plus 9 plus e3, you just plus 9 plus e3, and then simplify it. You will get this is your tangent lines here. Okay, that's it. So like for this lecture series, we talk about 2 formulas, right? So one is the power rules, right? So the power rule, so general power rule, x to the nth power, right? So that's the x to the nth power. How do you do that? And then we also talk about the best, I like the best is exponential function. So if it's exponential function, the derivative just be itself. It's super easy there. Okay, that's it. I like chapter 3. It's a very mechanical chapter, you know. They give you the formula, you just need to practice, okay? Of course, practice make you getting better in the math here, right? So don't forget to practice a lot, you know, by using the different rules here. All right, that's it. And talk about the next 2 rules in our next video. We're going to talk about some fun rules. We're going to talk about the product and the quotient rules. All right, that's it. And nice talk to you. And looking forward to talk to you in our next videos here. Okay, bye.